The next thing I want to talk about today in terms of models is degrees of freedom. Oh my goodness, it's a typo. So if we talk about degrees of freedom, when we're talking about models, what we're talking about is how many parameters we must estimate from our data. So different kinds of probability distributions have different numbers of parameters. And every time you have to estimate a parameter from your data, you're using up a piece of information. So for example, if you have a normally distributed data set, it has two parameters, the mean and the standard deviation. So you need at least two variables to calculate those, two observations to calculate those, right? If you have Bernoulli distribution, which is success or failure, there's only one degree of freedom. That's the proportion of successes. So once I tell you how many successes there are, once I tell you the chances of success, then you can automatically calculate the chances of failure as 1 minus the chance of success. So that's why we say it's a degree of freedom. So once we have defined the chance of success, the chance of freedom, the chance of failure, can't vary. It's not free to vary. We know what it is. So a Bernoulli process is a discrete random process with two outcomes. If you have more than two outcomes, then for each extra outcome you get, you add another degree of freedom. So those two outcomes leads to 1 degree of freedom. 15 outcomes would lead to 14 degrees of freedom. So the number of degrees of freedoms in a discrete process is equal to the number of outcomes minus 1. And so, for example, that hopefully makes sense if generalizing to the Bernoulli. Going back to the Gaussian, if you learned the sample standard deviation formula, the denominator in that is the sample size minus 1. And we need the sample size minus 1 because we had to use a degree of freedom to estimate the mean. Another way of thinking about that is if I give you a data set, if I give you a variable, and say there's 10, I tell you there's 10 observations in it, but I only give you 9 of them, but I also give you the mean, then you can figure out what that 10th observation is. It's not free to vary. So that's another way of thinking about how degrees of freedom work. So there'll be a number of cases where we encounter the term degrees of freedom in this course. And generally speaking, it has to do with how much information we've used up in our parameter estimation.